Sometimes we need to solve an equation which has x's on both sides. Our goal should be first to move the x's together onto one side, and then isolate the x variable using the techniques that we'd used in previous video. So we get to decide which one we want to move. If we want to move the negative 6x or the 6x. In this case, I'm going to move the negative 6x because I want to create a positive coefficient of x. That makes things just a little easier. Now, as you can see here, minus 6x and 6x are going to cancel. That'll leave us with a 10 on the left and a 12x here on the right. And now it's transformed into a two-step problem where we can isolate the x one step at a time. Okay, once I have that, I'll just rewrite it here so that I can continue with my solving. Let's divide by 12 on both sides. X is 11. Okay. In this next one, I can decide to move the 7x or the 2x. Neither one is wrong, really, but I'm going to move the 2x because that will give me a positive x coefficient. Now you have to bring down everything else. That's good technique. See, the negative 7 comes down. We do the 7 minus 2x. That'll be 5x. You have to bring the equals down. We can cancel these and bring down our negative 52. Okay, now we'll add the 7. 5x equals negative 45. Divide by 5. X is negative 9. All right, down here, I'm going to move the x over. Okay. That makes 5x. Yeah, 5x. Then we will subtract 7. Negative 10 equals 5x. So negative 2 is x. All right, I hope that makes those types clear. Next, what we're going to look at is how to simplify an equation before solving using the distribution technique. We see here that we've got a 4 that needs to be sent to the x and the negative 2. We also have a negative 2, which has to be sent to the 3 and the x through multiplication. Let's rewrite the equation. Now here we're not solving yet, we're just simplifying the left and right side to get it ready for the algebra of solving. So let's see, we'll get 4x minus 8 plus 6 equals 6x minus 6. And this last one is a little tricky. You have to take the negative with the 2. Sometimes people miss that. It's supposed to be minus 2x at the end. Okay, because it's negative 2 times x. All right, now we want to go farther in our simplification. We want to do what's called combine like terms. Now, the 4x and the 6x and the negative 2x are like terms because they're all attached to an x, you know? But the numbers are like terms as well. They're just numbers. And in order to simplify, we just want to combine numbers with numbers and variables with variables. So we'll get 4x minus 2 on the left, and then here we want to do 6x minus 2x. That makes 4x minus 6. Okay, great. Now it looks like a problem with x's on both sides that we can try to solve. So I'll move the 4x over. And an interesting thing happens here. X's cancel on the left and the right. So it's like, oh, what do we do now? Well, you still have to bring down the equals. And you have to bring down what's left, the negative 2 and the negative 6. All right, now we want to look at our results, which says negative 2 equals negative 6. And we want to ask ourselves, is that a false equation or a true one? And since negative 2 is a different number from negative 6, we see that this is a false equation. And, you know, we were trying to solve for x to get x alone, but now it's like, well, what do? We don't have any x's anymore. What this reveals when you get a false equation like that is that there's no solution to the equation. No matter what value you put in for x, it's never going to make the equation true. Okay, so that's the interpretation of a false equation. Let's try the next one. Send the 5 to the negative 3, you get negative 15x plus 5 minus 1. Bring everything else down. That's good technique. Bring everything else down except for the change that you made. In this case, the only change I made was the distribution. Everything else remains the same. Okay, now I'll combine those numbers. 5 minus 1 makes 4. Okay, I'm going to bring the 15x to the other side. It's going to give us 4 equals 7x plus 4. Subtract 4. And this is a tricky spot too. When you have an entire side cancel like that, you can't get rid of the equals. That's the thing. A lot of times people want to just get rid of the equals at that point, but you can't. Gotta keep the equals. So what goes over here? 0. Now we can continue to solve it. So x is 0. That's the solution. All right, for this next one, notice that there are parentheses around the 10x plus 13, but you know what? If it was written like this, you'd still get the same answer. Because, see, you'd do the addition before the subtraction anyways, because it's on the left. So those parentheses are actually meaningless there. So we'll just get rid of them. Let's distribute the 5, though. Okay. interesting. So in this problem, we notice that the left side is identical to the right side. That's a special case too, called an identity. And let's just try to solve it if we can. The 10x's cancel on both sides. And we get 10 equals 10. All right, so our x's have gone, so now we have to be very careful about how we interpret the results, just like before. Is this one a false equation or a true equation, though? Well, this one is true. When that happens, it's a special type as well. It's not no solution, though. It's what is called infinite solutions. And when that happens, no matter what x you plug in, you can plug in any value at all, that equation is going to come out true no matter what. You can try it for yourself. Pick an x, plug it into the left and right, and you'll see it's going to come out a true equation. So every single number will check. Another way to write this is all real numbers are solutions. Okay, let's just try these last three here. There's some interesting things that happen with them. Let's see. So I'll distribute that and get 4x minus 12 plus 8 equals 8x minus 24. 4x minus 4 equals 8x minus 24. Let's move the 4x over. Let's see, we'll get negative 4 equals 4x minus 24. Okay, let's add to both sides. We'll get 20 equals 4x. X is 5. Here we have to distribute twice on a side. We're going to get 2x plus 6 plus 2x minus 2 equals 5x minus 7. All right, let's go ahead and identify the like terms here. These are like terms, so the numbers are going to be like terms as well. 2x and 2x makes 4x. 6 minus 2 makes 4. Okay, subtract my 4x. We're going to get 4 equals x minus 7. Okay. Now, what if we have fractions with denominators involved? A lot of times with solving equations, we don't want to deal with denominators unless we absolutely have to. So let's try to get rid of those denominators just right off the bat here. What I want to find is what's called a least common multiple of the denominators of 3 and 4. So I want to think of some numbers whose factors are 3 and 4. And the number 12 comes to mind. And so one of the tricks that we can use, if we can identify a number who is both divisible by 3 and 4, is we can multiply both sides of the equation by any number of our choice. As long as we do it equally to both sides, we can't go wrong. So I'm actually going to multiply that 12 on the left side and the right side. The reason I'll do this is because 12 divided by 3 is going to come out an integer, and 12 divided by 4 is going to come out an integer as well. So if you do 12 times 2 over 3 here on the left, you'll get 8. And if you do 12 divided by 4 on the right, you'll get 3. So I was able to get rid of the denominators pretty easily because I multiplied by the least common multiple. It's a really useful trick. Now I'll just distribute. Then we can solve it. I'll bring the 3x over to the left. And once you get kind of experienced at this, you can actually do more than one change at one time. So I'm going to bring that 32 to the right in the same line. And let's see, we'll get 5x equals 35. Therefore, x is 7.